Good morning children. Welcome back to the science class. Are you all happy children? Did you all go through the previous lessons? Today I am going to take a new topic in physics, that is about light. So what is light children? Light is a form of energy and light travels in the form of waves. But we cannot see the waveform because the wavelength of light is very small. Now the path traveled by light, we call it as the ray of light, and the group of rays together we call them as beam of light. Children, we know some objects, they emit light on their own. Now do you know which objects they emit the light on their own? For example, sun stars, they emit the light on their own, they are called as luminous objects. And some objects, they takes the light from the luminous objects. They are called as non-luminous objects. For example, moon is a non-luminous object. When we want to see any object, we use our eyes to see the object. But in a dark room, you won't be able to see the object. Only when the light rays fall on the object, you will be able to see the object. Now today we are going to learn about certain topics like properties of light, refraction of light, dispersion of light and scattering of light. First let's see about the properties of light. We already know that light is a form of energy. That is the first property. Then even though light travels in the form of waves, they travels in a straight line. And then they do not require any medium for propagation. That is, the sound waves, they need a medium for propagation, but the light waves do not need any material medium for propagation. And the speed of light is 3 into 10 power 8 meter per second. And we know light travels in the form of waves. So it will have a wavelength. So the length of one wave is wavelength and the number of waves traveling for 1 second is frequency. So the wavelength is denoted by the lambda and frequency is nu. So c is equal to nu lambda. That is the velocity of light. Now different color light has different wavelength and frequency. Can you see here? Each color has a different wavelength. Among the visible light, violet light has the lowest wavelength and red light has the highest wavelength. When light travels from one medium to another medium, part of the light is reflected and part of the light is refracted. Now let's see the refraction of light. So when light travels from one medium to another medium, it will not go straight. It will deviate from its path. So that is called as refraction of light. The bending of light from its path we call as the refraction of light. So when light travels from one medium to another medium, it will not go straight but it will deviate from its path. So this we call it as the refraction of light. And the speed of light differs in different medium. It will not be the same. Velocity of light is more in a rarer medium and less in a denser medium. So inside the water, the velocity of light will be less than in the rarer medium. Let's see the laws of refraction. When light travels from one medium to the other medium, the light gets refracted. So the incident ray and the normal at the point of incidence and the refracted ray, they all lie on the same plane. So the incident ray, the refracted ray and the normal at the point of incidence, they all lie on the same plane. Now let's see the second law, which is called as the Snell's law. So in the same way, when light travels from one medium to another medium, the light gets refracted. So the angle between the incident ray and the normal is called as angle of incidence. And the angle between the refracted ray and the normal is called as angle of refraction. So the refractive index of the air medium will be equal to mu1 and the refractive index of the denser medium is equal to mu2. So sin I by sin R is equal to mu1 by mu2. So according to the second law, the ratio of the sine of the angle of incidence and the angle of refraction is equal to the ratio of the refractive index of the two media. Now when light travels from one medium to the other medium, it gets bent. So that is called as the refraction of light. So when light travels from rarer medium to denser medium, it bends towards the normal, and when it travels from denser medium to rarer medium, it bends away from the normal. Now let's learn about the refraction of composite light. If a source produces a light of single color, then it is called as the monochromatic source. So monochromatic source means it produces a single color. Now if a light produces different colors, then it is called as the composite light. So if a source produces different colors, then it is called as the composite light. Sun is a good example. It is a composite light because it consists of various colors of wavelength. Now let's see the dispersion of light. When a beam of light or composite light is refracted through any transparent media like glass or water, it's split up into different colors. So that is called as the dispersion of light. So when white light travels through a prism, it's split up into different colors. The band of colors is termed as spectrum. The spectrum consists of the following colors like violet, indigo, blue, green, yellow, orange and red. Look at these colors. Now these colors are represented by an acronym WIPGR. Different color lights are bent through different angles. Angle of refraction is smallest for red and highest for the violet. So when light travels through a prism, it gets refracted, and the angle of refraction for red color is less than the violet color. Let's see the scattering of light. When sunlight enters into the atmosphere, the light gets scattered in all directions. That is, when it enters the Earth's atmosphere, the atoms and molecules of different gases present in the atmosphere interact the light in all possible directions. That is called as the scattering of light. Now the beam of light is redirected in all directions when it interacts with a particle of the medium. The interacting particle of the medium is called as the scatterer. So when the light interacts with the particles, it gets scattered. So the particles are called as scatterer. Now let's see the types of scattering. There are two types of scattering. They are the elastic scattering and the inelastic scattering. Let's first see what is elastic scattering. If the energy of the incident beam of light and the scattered beam of light are same, then it is called as the elastic scattering. Next, let us see about the inelastic scattering. If the energy of the incident beam of light and the scattered beam of light are not the same, then it is called as the inelastic scattering. The nature and the size of the scatterer results in different types of scattering. Let's see the different types of scattering. They are the Rayleigh Scattering, Mice Scattering, Tyndall Scattering and Raman Scattering. Now let's see the Rayleigh Scattering. The scattering of light by the molecules of the gas in the Earth's atmosphere is called as the Rayleigh Scattering. Lord Rayleigh was the first to deal with scattering of light by air molecules. The basic process in scattering of light is absorption of light by the molecules followed by re-radiation in different directions. The strength of scattering depends on the wavelength of light and also the size of the particles which cause scattering. The amount of scattering is inversely proportional to the fourth power of its wavelength. This is known as Rayleigh scattering law. Hence, the shorter wavelength are scattered much more than the longer wavelength. The blue appearance of sky is due to scattering of sunlight by atmosphere. The scattered radiation causes the sky to appear blue. At sunrise and sunset, the rays from the sun have to travel the large part of the atmosphere than known. So the blue light scattered away and only the red light, which is least scattered, reaches the observer. Now let's see about my scattering. My scattering takes place when the diameter of the scatterer is similar to or larger than the wavelength of the incident light, and it is also known as elastic scattering. So we already know the particles, when the light falls on the particles, they get scattered. When the diameter of the particles are similar or larger than the wavelength of the incident light, my scattering takes place. Now my scattering is caused by pollen, dust, smoke, water droplets and other particles in the lower portion of the atmosphere. My scattering is responsible for the white appearance of the clouds. When white light falls on the water drop, all the colors are equally scattered, which together form the white light. Now let's see about the Tyndall scattering. So when beam of light enters into a dusty room through a window, then its path becomes visible to us. This is because the tiny dust particles present in the air of the room scatter the beam of light. This is an example for Tyndall scattering. The scattering of light rays by the colloidal particles in the colloidal solution is called Tyndall scattering or Tyndall effect. Now let's see some examples of colloidal systems from our daily life. Foam is an example, milk, fog or smoke, detergents, gel, blood, paints and cosmetics. So these are some of the examples of colloidal systems in our daily life. Let's see about Raman scattering. When a monochromatic light falls on a substance, it gets scattered in all directions. Can you see? It gets scattered in all directions. So when a parallel beam of monochromatic light passes through a gas, liquid or a transparent solid, the part of the light rays are scattered. So light rays get scattered in all directions. So the scattered light will have some additional frequencies other than that of the incident frequencies. So the lines whose frequencies have been modified in Raman effect are called Raman lines. If the scattered light has the frequencies other than that of the incident frequencies, they are called as the Stokes line and the anti-Stokes lines. If it has the same frequency as the incident frequency, then it is called as the Rayleigh line. The spectral lines having the frequencies lower than that of the incident frequencies are called Stokes line. And the spectral lines having the frequency higher than that of the incident frequency are called anti-Stokes line. This series of lines in the scattering of light by the atoms and the molecules is known as Raman spectrum. Children, let's do a small recap on properties of light. Hey Adish, shall we revise the properties of light? Yes, Alan, we can revise the properties. Tell me the first property. The first property is light is a form of energy. Very good, very good. And what is the second property? I'll tell. Light always travels along a straight line. Very good. And what is the third property? I'll tell. Light does not need any medium for propagation. It even travels through vacuum. I'll tell the fourth property. The speed of light in vacuum is 3 into 10 power 8 meter per second. Is it correct? Yes, very good. Correct. Now I'll tell the formula to calculate the speed of light. C is equal to nu lambda. Excellent. Now what is the seventh property? Hey, you didn't tell the sixth property. First tell the sixth property. Okay, the sixth property is different color light has different wavelength and frequency. Among the visible light, violet light has the lowest wavelength. I'll tell. Red light has the highest wavelength. When light is incident on a surface, it is partly reflected and partly refracted. Oh, very good, very good, very good. Children, don't forget to watch the enrichment link about what light can teach us about the universe.